In order to determine the exact 6 trigonometric values, we must have all the sides of our triangle. Now the triangle is already half drawn for you. You just got to go like this back to the x-axis so that you can get a triangle going on here. And because the point, the coordinates say 4, 3, your x is 4 and your y is 3. Okay, so you have the labels of these two legs. Now this is not inside the unit circle, so don't even try. If you guys did Pythagorean theorem, you would get a 5 for the hypotenuse. I know it's a 5 because 3, 4, 5 is a Pythagorean triple. It's the most popular one out there, so if you don't get it, then what are you doing here? Okay, now I am going to do my 6 trigonometric functions. We have sine, cosine, tangent, and then what's after that? Let's do cosecant next. Yeah, let's do that. Cosecant theta. Secant theta, and the reason why I'm doing cosecant theta because I want these guys to kind of align right there, sine and cosecant, and then cotangent theta. Now all these thetas are the same theta. All these thetas are the theta inside of our triangle, and so since we know that SOHCAHTOA shot our cow, shot your cow, opposite over hypotenuse, like all that stuff. We can go, hey, sine is opposite, which is 3 over hypotenuse. And so the answer is 3 over 5. Cosine would be 4 over 5. Tangent would be 3 over 4. I'm just remembering SOHCAHTOA here. SOHCAHTOA. That is, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, so the next one is shot your cow, and I like saying shot your cow because it sounds like someone shot your cow. I know you guys already know this. Let's see, shot your cow, cow. So secant is hypotenuse over adjacent. Cosecant is hypotenuse over opposite. Cotangent is adjacent over opposite. And so those are my other 3 trigonometric functions. And so since cosecant is hypotenuse over opposite, that's the reciprocal of sine. So I could just take sine and flip it. I flip cosine for this one, and I flip tangent for this one. So that's how you do A. Oh. Now, what is the difference? What is the major difference of this coordinate than this coordinate right here? Negative. It's the negative. You are correct. Because when I do my triangle right here, we would have 8 and then negative 15. Okay, that 15 is negative. That's weird. We have a negative distance, but since we're in a coordinate plane, we're allowed to have a negative side because there's such thing as getting negatives, negative trig answers to trigonometric functions. So this is theta, technically. Technically, that's theta. But what angle are you referencing? Like, in order to figure out what is the opposite side and what is the adjacent side. This angle right here. That is the angle you're referencing when you're trying to figure out what is the opposite and what is the adjacent. Now, remember, I talked to you guys about reference angles before. In the unit circle, the reference angles that we are most commonly using are 30 degrees, 45 degrees, and 60 degrees. Or, in other words, pi over 6, pi over 4, and pi over 3. Okay, but the reference angle is not limited to those. Those are just the most common. If we're in the unit circle, those are the reference angles we are using usually. All right, so how do we do this? Well, we got to rewrite all that stuff that we wrote before. Sine theta, cosine theta. Man, I wish there was some cool shorthand, but there's too many S's and C's. Dang it. Tangent theta, cosecant theta. Dang it. Okay, secant theta. That should be a C right here. And then cotangent theta. I'm all trying to be fast, but I just keep messing up.
All your thetas look so different.
Don't make fun of my thetas. Yeah, my thetas look like a 0 with a toupee. Has like one little hair going down. Some people do their thetas like this. But that looks too close to a no solution to me. I don't like that. I like the little toupee look. Okay, so we have sine, which is opposite, which is negative 15. Oh, we didn't find our hypotenuse yet. Oh, poo-poo face. Okay, so we have 8 squared plus negative 15 squared, which doesn't matter about the negative because when you square it, it goes away, equals c squared. So this is going to be 64 plus 15 times 15. Is that 225?
Yeah.
225 equals c squared. And then if I add those dudes together, I get a 9 and I get an 8, I get a 2. Oh man, is that a perfect square right there? I don't remember if it's a perfect square. Hold on, let me think about that. All right, 17 it is. So this hypotenuse is 17. One thing to note, hypotenuses are always going to be the positive numbers. Always.
Wait, hold on, what?
Hypotenuses are always going to be the positive numbers. So adjacent sides and opposite sides, one of those can be negative, okay? The co-height or the height, you know. All right, so this would be 17 right here. And then the next one's going to be 8 over 17, but that's positive. Cosine's positive there. And then tangent is going to be negative 15. That's opposite over adjacent. Adjacent is 8. Cosecant is the reciprocal of sine, so I'm just going to flip the 17 or the 15 over 17 to get 17 over 15. And then secant, I'm going to flip the cosine, which is 17 over 8. And then for cotangent, I'm going to flip the tangent. That's going to be negative 8 over 15. Note which trig functions are positive here. What is the only trig function that should be positive in this quadrant?
Cosine.
Cosine. Because all students take calculus. Actually, that's not why. That's just a stupid acronym to help us remember this. Okay, so all trig functions are positive in this quadrant. Just sine is positive in this quadrant. Just tangent is positive in that quadrant. And just cotangent, I'm sorry, not cotangent. Just cosine is positive in this quadrant, which is true here. See cosine there? He's positive. And his cousin's also positive, secant.
What was the Asian one?